So when I was back in Laval University, we became interested by micronutrients and obesity after having observed a similar relationship amongst the participants of the Quebec Family Study. The Quebec Family Study is a study that involves families from French descent living in the Quebec City area. And amongst the numerous questionnaires we administered to the participants, there was one simple question: do you consume vitamins or dietary supplements? And when we compare those who answered yes to this question, so the consumers of vitamins and dietary supplements, to those who answered no, we realized that men, consumers of vitamins and dietary supplement, had a significantly lower body weight and fat mass after adjusting for confounding variables, and tend to have a significantly higher resting metabolic rate. In women, although a tendency was observed for lower body weight and fat mass, the main differences were at the level of eating behaviors. So women, consumers of vitamins and supplement, had a significantly lower disinhibition and susceptibility to hunger score, which is associated with a lower BMI and less food intake. So we thought these results were very interesting, but we couldn't really assess, since the question was not precise enough to know more about the micronutrient intake of individual. It convinced us to realize an intervention study where we would assess the effect of a multivitamin and mineral supplement during a weight loss intervention on body weight, fat mass loss, and appetite. So in the context of this study, 18 men and 22 obese women were randomized either to receive a multivitamin and mineral supplement or a placebo in complement of a 700 kilocalorie energy restriction, and the study lasted 15 weeks. At the end of the study, we noticed that in men as well as in women, there was a significant decrease in body weight and fat mass, but no difference between treatment groups. So both groups reacted the same. However, we also measured appetite ratings of our participants in the morning, in the fasting state, as well as following a standardized breakfast meal. And when we look into these data, we realize that the placebo women that you can see in red had an increase in their fasting desire to eat and in their desire to eat following the breakfast, as well as an increase in their hunger level, which is a result we were expecting, since these participants lost a significant amount of body weight and appetite usually increased following body weight. However, the woman who received the multivitamin and mineral supplement, and that you can see in yellow, experienced a significant decrease in the desire to eat, as well as in hunger and prospective food consumption, suggesting that the multivitamin and mineral supplementation prevented the increase in appetite that usually accompanies body weight loss, and suggest a potential role for vitamins and minerals in the control of appetite and ultimately energy intake. So we thought that was very interesting and was probably deserving more investigation. But we thought as well that it would be interesting to narrow our range of investigation in order to find out if one or two vitamins or minerals would have a greater impact than others. And it's about at this time that other results obtained in our lab in Quebec City directed us towards calcium and vitamin D. So a colleague of mine at the time, Mélanie Jacquemin, analyzed the results from the Quebec Family Study in a different manner that I had did it. So she removed participants who were reporting consuming vitamins and dietary supplement, and divided the participants according to their usual calcium intake they were reporting. And she found out that in women, those who were reporting consuming less than 600 milligrams of calcium per day had a significantly higher body weight and fat mass compared to those who were reporting eating more than 600 or 1,000 milligrams of calcium per day. So we thought that was very interesting, and we decided to conduct another intervention study and to supplement, this time, 63 overweight women with either a placebo or a calcium plus vitamin D supplement in combination to their 700 kilocalorie energy restriction. At the end of the study, there was no significant difference between the two groups. However, we thought that this 1 kilo difference was perhaps suggesting a tendency. And we decided to go farther and to consider in the analysis only the very low calcium consumers, which were the women we were targeting at the beginning based on the Jacquemin results. But because of time pressure, we had increased our inclusion criteria to 800 milligrams per day. But when we consider only the very low calcium consumers, we notice a significant difference between the two groups. And when we tried to explain this difference, we went back to the literature and looked at the different hypotheses, some more controversial than others, that have been put forward to explain the effect of calcium or dairy on adiposity. In our study, we measured resting metabolic rate and substrate oxidation and found no difference between the two groups of very low calcium consumers women, so eliminating this last hypothesis. We did not measure lipolysis, neither core temperature, neither fecal fatty acid excretion, but we can estimate this last variable to have been around 80 calories per day, as observed in the Jacobson et al. Study. However, 80 calories per day cannot explain fully the difference in body weight loss between the two groups, which average more at 300 kilocalories difference per day if we extrapolate it over a 15-week period. However, in our study, we also measured the food intake of participants using an ad libitum buffet test meal. So participants came in baseline, ate the buffet, and stopped eating when they were not feeling like eating anymore, and we repeated the same test after 15 weeks. And what we observed is that the significant decrease in lipid intake in the very low calcium consumers, calcium plus D group, combined with the increase in lipid intake, was representing a difference of 230 kilocalories. And if we assume that their food choices during the buffet test represent the way they managed to change their eating habits during the 15 weeks intervention, then the difference in lipid intake became the variable measured in our study that best explained the difference in body weight loss. And we thought that this result might represent a new hypothesis explaining the effect of calcium on body weight loss or of other minerals on body weight loss. Indeed, it is well known that in animals, when you restrict them of a mineral, they develop a specific appetite for this mineral. And this is true for calcium as well. So you can see here the amount of 4 different solutions with different calcium chlorine concentration drank by 3 groups of rats. And you can see that the group of rats that have been deprived during 6 weeks of calcium drank in a preferential manner the solution with the highest concentration, which led the authors to conclude that rats deprived of an adequate source of calcium developed a calcium appetite. And this is a hypothesis that has been put forward by Michael Turdoff. But as Turdoff mentioned, it is not known if in humans such a specific appetite exists. And even more, if it does exist, it would be very difficult to identify, since it would probably be associated with the complex flavor profile that characterizes the most appreciable sources of calcium. However, this is also interesting, since it could mean that due to the co-occurrence of calcium and fat in a lot of types of food and the learned association between these two nutrients, it could lead some calcium deficient individuals to accidentally overconsume fat or food in their search to increase their calcium intake. And that could be true for other macronutrients.